Hey everyone, it's that Math Magician. On this video, we're going to take a look at probability, but more specifically, how we can use a tree diagram to help us solve a problem. Now before we jump into this, we got to have a situation where we can use a tree diagram. And we do have that situation. Right here we have a problem where Marcus has 3 pairs of pants, black, blue, and green, and he has 4 shirts, black, red, orange, and blue. And we want to figure out in a second, what are the probability of him wearing certain colors in his outfit. Now before we do that, we first need to map out his sample space. Remember, sample space just means the possible outcomes he has for picking his outfit. Really, we're looking at all the different combinations for his pairs of pants and his shirts. And one way that we can map out his sample space is with a tree diagram. A tree diagram is a visual representation for this, and we're going to see all the different branches of possibilities that Marcus has. So let's go ahead and see if we can work this out. Now we first have to decide what we want to map out first. Do we want to map out his pairs of pants, or do we want to map out his shirts? I think we'll start with his shirts. Notice that Marcus has 4 different shirts to choose from. So with my tree diagram over there, I'm starting with my first point here. I'm going to map out 4 different possible outcomes, each representing a different color shirt. Notice he could either pick black or he could pick red. The next color would be orange, and the final one would be blue. Now it does not say that he has a higher chance of picking one color over the other. So it's safe to assume for us then that each shirt has an equal chance of being picked. If each shirt has an equal chance of being picked, that means they have a 1 in 4 chance of being chosen. So on my tree diagram here, I'm going to label every branch here as 1/4, just so I can tell the reader that he has a 1 in 4 chance of picking that shirt. Perfect. That is our first set of branches representing our shirts that Marcus can pick. The next thing is now we got to show his pairs of pants. And he has 3 pairs of pants there. So notice that as I move up this first branch, and let's say he's chosen his black shirt, that means then he has 3 pairs of pants to choose from. He can either pick the black pair of pants, the blue pair of pants, or his green pair of pants. And I'm going to label that again, just like we did earlier, showing each letter as a possible outcome for Marcus to choose. But notice now that I really need to take that section of the tree diagram, I'll go ahead and copy it, and I'm just going to need to paste it. Because if he chose that for the black pair of pants, for the black shirt, then if he chooses a red shirt, those are his outcomes for choosing his red shirt. The same thing can be said when he picks the orange shirt. He's going to pick one of these 3 pairs of pants. And then finally, his very last one down here, is going to be, if he chooses that blue shirt, these are the 3 pairs of pants that Marcus can choose. Now notice that what this tree diagram does is it really just shows you all the different branches for Marcus to choose from. But we haven't finished it just yet. We gotta add in the fractions for the pairs of pants. Again, 3 pair of pants to choose from. Each pair is equally likely to be chosen. So every branch here along this tree diagram on the second set is going to be 1 in 3 because there are 3 pairs of pants and he is equally likely to choose each of those pairs of pants. Now, you might be thinking, if you already watched the video on area model, that this method is a little messier. And I would agree. It is a little messier because we have to visually show every single branch for every combination. And just imagine, what if he didn't have 4 shirts? What if he had 10 shirts and maybe 20 pairs of pants? You could see how crazy this tree diagram could get. Now, when it's a simpler problem like this, then it's a little easier to use. But when the more choices you have, the tree diagram will get a little crazier in its representation. But that is our tree diagram. The only last thing to do now is to show all the different possibilities. Notice that I can represent that by saying Marcus chooses a black shirt and a black pair of pants. I'm crossing that 1/4 and that 1/3. I need to take those two fractions and I need to multiply them. But notice that as I move across any of the possible outcomes for any shirt combination here, it's always going to be 1/4 times 1/3. This is a very simple problem. And so because of that, every single possible combination here is going to be 1 out of 12. So I'm going to go ahead and label that into my tree diagram to show that every possible outcome here has a 1 in 12 chance of occurring. Now let's go ahead and start answering some questions with this. Let's figure out, what is the probability that Marcus is going to wear something blue? What that means is I need to look on my tree diagram and figure out all the possible branches there that lead to Marcus wearing a blue piece of clothing. Notice that if he chooses a blue shirt, that every possible outcome here is going to end up with him wearing blue. So at the moment, we have 3 out of 12 choices there. 3 out of 12 choices on the bottom there has him in a blue shirt. But now we have to go through and look at when he's wearing blue pants. And he could be wearing blue pants with an orange shirt, with a red shirt, and with a blue shirt. So notice that all the branches that I've highlighted 1, 2, 3, 4, 5, 6. So there are 6 possible ways for him to be wearing blue out of a total of 12 outcomes. So what's the probability of Marcus wearing blue? It is 6 out of 12, which really reduces to 1/2. That's how you use the tree diagram. You identify the branches you need in order to show what you're looking for. Let's do one more question. What's the probability that Marcus is going to be wearing orange? Again, let's look at our branches here and see, when is he wearing an orange item of clothing? Well, he only has an orange shirt. So when I go down this branch where he's wearing the orange shirt, he has 3 pairs of pants to choose from. So those are the options that he has for wearing something orange. 3 out of 12, which is going to reduce to 1/4 or 25%. If you watched the area model video before this one, you're probably noticing that these fractions are the same, and they should be the same because it's the same problem, so it would have the same answer. Area model and tree diagram are doing the same work in showing you what the outcomes are. So the answers aren't going to change, there's just going to be different ways of representing that. Notice in our sample space here, we can visually see all the different branches that are occurring. With area model, it's not as so simple as that, but they're both going to get us to that right answer. It's That Math Magician, and I'll see you on the next video.